Welcome to Pulsar's Career Point. This is a video for the student of class 11 on practice series for chapter review test on the chapter periodic classification containing the most probable questions from the chapter periodic classification. Let us come for the different types of questions. This is strictly as per the pattern of CHSE Odisha, having 4 marks 20 and time duration is 45 minutes. Let us come for the time distribution. Question paper reading and understanding is 5 minutes. Question number 1 covering 6 questions which requires 12 minutes in all. And question number 2 is of 6 marks. This is to be answered within 12 minutes. And the question number 3 contains 2 4 marks questions which is total mark is 8 and must be covered in 16 minutes. Means we must have to remember that every 1 mark answer must be written within 2 minutes, as a result of which the time can be adjusted. Welcome to all of you to the objective section. Here all the questions are compulsory, consisting of multiple choice questions. Each question requires not more than 2 minutes to write the answer. Thus, the total time allotted for this section is 12 minutes. Out of the following, which is the electronic configuration for the elements of S? Option A, NS2, NP126, NS1 or 2, N-1D, 1 to 10, NS1 or 2, none of these. Out of these following, which is the electronic configuration for the S block element? The electronic configuration for S block element is NS1 or 2. For P block element, it is NS2, NP126. For D block element, it is NS1 or 2, N-1D, 1 to 10. So, we must have to understand the question first. Which electronic configuration is asked? If it is asked for S block element, then the answer will be NS1 or 2. That is option C will be the correct answer. But if this question is for P block element, then option A will be the correct answer. That is the general electronic configuration for the P block element is NS2, NP126, and for D block element it is NS1 or 2, N-D, 1 to 10. So before choosing the correct option for the electronic configuration, we must have to confirm which electronic configuration is asked, whether it is for S block, P block or D block or F block elements. Out of Na plus and Na, which is smaller? Na plus is smaller because here 10 electrons are attracted by plus 11 nuclear charge, but in case of Na, 11 electrons are attracted with plus 11 nuclear charge. So, as lesser number of electrons are attracted in case of Na plus, it is smaller than Na. State Mendeleev's periodic law. The physical and the chemical properties of the elements are the periodic function of their atomic masses. State modern periodic law. The physical and the chemical properties of the elements are the periodic function of their atomic numbers or electronic configuration. Name the shortest period in the periodic table. How many electrons are present in it? The shortest period in the periodic table is the first period. Only 2 elements are present in it, that is hydrogen and helium. Arrange the following in the increasing order of radius: Mg2 plus, Ne, F minus and Na plus. All the 4 species contain 10 electrons in their outermost in their cell. So, but in case of Mg2 plus, 10 electrons are attracted with plus 12 magnitude of nuclear charge. In case of Ne, these 10 electrons are attracted by plus 10 nuclear charge. In case of F minus, 10 electrons are attracted by plus 9 nuclear charge. In case of Na plus, 10 electrons are attracted by plus 11 nuclear charge. So, the attraction is maximum in case of Mg2 plus. So, Mg2 plus is smaller in radius then Na plus, which is smaller than Ne, which is smaller than F minus. Now, welcome to all of you to the subjective section of this. We have 3 short questions to be answered out of 4. Each question requires not more than 4 minutes to write the answer. In total marks will be 6 marks, which is to be answered within 12 minutes. Come for the first question. What is electron affinity? Describe its periodic trend. आम इलेक्ट्रॉन एफिनिटी कहले कौन बुझा the amount of energy released when an electron is added to the outermost orbit of an isolated gaseous atom to form gaseous anion is called electron affinity. X gaseous neutral atom, whenever electron is added to it, it becomes X minus gaseous ion by the evolution of energy EA, where EA is the electron affinity of the gaseous nonmetal X. Periodic trend. Along the periods, the electron affinity increases from left to right due to decrease in atomic size and increase in nuclear force of attraction to the outermost electron. What happens along the groove? From top to bottom along the groove, electron affinity goes on decreasing with increase in atomic size. Come to question number 2. What is electronegativity? Write its predicted. Electronegativity means the capacity or tendency or relative power of an atom to attract the shared pair electrons in a covalent bond towards itself is called electronegativity. Predicted. Along the periods, the electronegativity increases from left to right due to decrease in atomic size and increase in nuclear force of attraction to the outermost electron. But what happens along the groove? From top to bottom along a groove, the electronegativity goes on decreasing with increase in atomic size. Now come for the question number 3. Describe the drawbacks of Mendel's periodic table. What are the different drawbacks of modern Mendel's periodic table? The position of hydrogen is not clear. In this table, no attempt has been made to separate the metals from the non-metals. Similar elements are separated in this table. Dissimilar elements are placed together in the same group in this table. Certain elements having higher atomic weights were placed in this periodic table before they possessing the lower atomic weights. These are the different drawbacks of Mendel's periodic table. Let us come for the question number 4. Describe the periodic trend of atomic size. What happens to atomic size as you proceed from left to right in a period? Along the period, the atomic size as well as the atomic ionic size decreases from left to right due to increase in nuclear charge with same number of shells or orbits. Thus, size of lithium is greater than size of beryllium is greater than size of boron. Along the group, what happens? From top to bottom along a group, the atomic radius as well as ionic radius goes on increasing with addition of new shells on orbit. Size of lithium is less than size of sodium is less than size of potassium. Now, we'll come to all of you to the descriptive section. Here 2 questions are to be answered out of 3. Each question requires not more than 8 minutes to write, as the maximum mark is 4. Now, come for the question number 1. Describe about the different periods of the modern periodic table. What are periods? In modern periodic table, the horizontal rows are called periods. There are 7 periods in the modern periodic table, namely first, second, third, fourth, fifth, and 7th period. First period corresponds to 1s subcell, so it contains only 2 elements in it, that is hydrogen and helium, with the shortest period in the periodic table. The second period corresponds to 2s and 2p subcell, so it contains 8 elements in it and it is a short period. The third period corresponds to 3s and 3p subcell but not 3d, because 3d has more energy than 4s subcell, so it contains only 8 elements in it, hence it is also a short period in the periodic table. The fourth period corresponds to 4s, 3d and 4p subcell but not 4d and 4f subcell, as they have more energy than 5s subcell. So it contains only 18 elements in it. It is a long period in the periodic table. The fifth period corresponds to 5s, 4d and 5p subcell but not 4a, 5d and 5f, as there is more energy than 6s. So it contains only 18 elements in it and it is also the long period in the periodic table. The fifth period corresponds to 6s, 4f, 5d and 6p, but not 5f, 6d and 6f because these are more energy than 7s. So it contains only 32 elements in it. It is the longest period in the periodic table. The seventh period is incomplete. What is ionization potential? What are the factors on which it depends? Write its periodic table. What do you mean by ionization potential? The amount of energy required to remove an electron from the outermost orbit of an isolated gaseous atom to form gaseous cation is known as ionization potential or ionization energy. M gaseous atom by observing ionization potential amount energy gives us M plus gaseous cation and an electron. Here P is the ionization potential of the gaseous element M. It is expressed either in kilocalorie per mole or kilojoule per mole or electron volts, where 1 electron volt is equal to 23.06 kilocalorie per mole. The second ionization potential is more than the first ionization potential. Factors affecting the ionization potential: atomic size. Ionization potential inversely proportional to atomic size. Thus, ionization potential decreases with increase in atomic size and increases with a decrease in atomic size. Nuclear charge. Ionization potential directly depends upon the nuclear charge. Thus, the ionization potential increases with increase in nuclear charge and decreases with a decrease in nuclear charge. Screening effect or shielding effect. Ionization potential is inversely proportional to screening effect or shielding effect. Thus, ionization potential decreases with increase in screening effect or shielding effect and increases with decrease in screening or shielding effect. Periodic time. Along the periods, the ionization potential increases from left to right due to decrease in atomic size and increase in nuclear force of attraction to the outermost electron. What happens along the group? From top to bottom along a group, the ionization potential goes on decreasing with increase in atomic size. Describe about the different groups of modern periodic table. What do you mean by groups? In the modern periodic table, the vertical columns are called groups. There are 18 columns in the modern periodic table, which are divided into 16 different groups. In the modern periodic table, the vertical columns are called as groups, and there are 18 columns in the modern periodic table, which are divided into 16 groups, which are named as 1A, 2A, 3rd B, 4th B, 5th B, 6th B, 7th B, B triple I, 1B, 2B, 3rd A, 4th A, 5th A, 6th A, 7th A, and 0. First and second columns are known as 1A and 2A groups. These are known as S block elements, as their last electrons are present in S subset. These are also known as normal elements. The elements of 1A are called alkali metals, and the elements of group 2A are called alkaline earth metal. 3rd to 12th columns are known as 3rd B, 4th B, 5th B, 6th B, 7th B, B triple I consisting of 3 columns, 1B, 2B group respectively. These are known as D block elements, as their last electrons are present in D subset. These are known as transition elements because their properties are in between S and P block elements. The 13th to 18th columns are known as 3rd A, 4th A, 5th A, 6th A, 7th A, and 0 group respectively. These are known as P block elements as their last electrons are present in P subset. The elements of 3rd A to 7th A are known as normal elements, and the 0 group elements are called inert gases. Thanks for watching Bhopal Sir's Career Point. Please like and share the video. Don't forget to subscribe my channel if you are watching it for the first time.